Now it's recording.
All right, welcome everyone to Unlocking Mathematical Thinking, Number Sense Routines for All Learners. So as Adam mentioned, I am Toni Galassini. I'm a professional learning specialist with the Office of Early Childhood with Chicago Public Schools. I am also an early childhood through sixth grade director on the board for ICTM. And Shantae, you want to go ahead and introduce yourself?
Yes, thank you, Toni. Good afternoon, everyone. My name is Shantae Allen. I am a K-5 math specialist with the Department of STEM, and I am one of the newest members of the ICTM as the EC6 director. I think I will be official this weekend.
All right, so if you haven't already done so, feel free to add into the chat where you're from, your role, and what grades you support. I saw we had some pre-K teachers. I saw we had some interventionists, some special ed teachers. We see a couple fifth, eighth, fifth through sixth. Also see some tutors from community colleges. Well, we welcome you all into this space. All right, so here's our objectives for today. We want to kind of understand the complex nature of number sense development and why it's important not only in those early elementary grades, but also in middle school. We'll also learn about 4 types of number sense routines, and we'll give you some various examples of each. We're going to engage in some of these discussion-rich number sense routines so you can actually put on your student hat and see what it's like to engage in them. And see how they help to support your students with developing that flexible thinking with numbers, deepening understanding of operations, and then addressing those gaps in prior learning. All right, Shantae is going to start us off though with let's doing some math, as we always start off our math sessions.
Absolutely. Good afternoon again to everyone. As Toni started off as a math department, we always like to get you immersed in some math right away. I did drop a copy of the participant deck in the chat for you as well, so you can feel free to follow along there. This routine should look very familiar to some of us, and it is a which one doesn't belong. The protocol for the routine is very simple. What I would like for you to do is I would like for you to think of which one of the numbers you feel doesn't belong. And more importantly, I want you to think of why that specific number does not belong. So go ahead and take a minute and think. And then once you have a response, go ahead and drop it in the chat. So again, which number doesn't belong? And more importantly, you have to type why you feel that number doesn't belong. All right. So I see some responses coming in the chat. Feel free to check that out. I'll elevate a few here. I do see a few people put 17. It's odd and it's a prime number. We have a couple people saying that. Ooh, interesting. 65 because the digits don't add up to 8. Okay. I see somebody else said 17 because the first digit is odd. Okay. I think that was a interesting one that I didn't come up with before. Anne said 17 because all the other numbers have an even digit. Okay. So I'm trying to see, I haven't seen anything for 44 yet. Anybody have a reason why they maybe think 44 doesn't belong? All right. Oh, Tammy said it was the doubles. Okay, only number that has a double repeat, double digit repeated. Okay. Toni, it doesn't look like I have access to advanced. So can you go to the next slide, please? So as you please continue to drop your responses in the chat if you would like to from our which one doesn't belong. But what we would like for you to kind of reflect on now, again, in the chat, how did this routine support number sense development? So think about your responses, maybe even think more so about what was going on in internally or mentally as you were looking at those four numbers? And maybe share a little bit around some of that in the chat. How do you think this number routine how do you think this routine supported number sense development? All right, I see some answers coming up in the chat here. Um, all right, so I see Kelly put in there around the math vocabulary that we need to use, and talked about using previous learning. Absolutely. Makes us think of number properties and related vocabulary, thinking about composite numbers and prime numbers. I love what Vanessa said, that every student can participate. We always want to think about when we do these number routines, is this going to create access for everybody? Will everybody have something to say? Definitely, definitely important. So we can go ahead and look at the chat for some more responses there. We'll go ahead to the next slides, Toni.
So what does it really mean to have number sense? Some teachers, when I ask them what number sense is, find it difficult to put into words. They might talk about different components of number sense, but they have that hard time kind of grasping collectively what number sense is. So let's take a look at what ICTM says about number sense. So as students work with numbers, they gradually develop flexibility in thinking about numbers, which is a hallmark of number sense. Number sense develops as students understand the size of numbers, develop multiple ways of thinking about and representing numbers, use numbers as reference, and develop accurate perceptions about the effects of operations on numbers. So number sense is a real broad term that refers to a group or set of skills that are really needed to perform those basic math operations. Teachers often say that number sense involves counting, and that if they can count, they'll master number sense quickly. But really, number sense refers to that deep understanding of how numbers work, and it really takes time for our young kiddos to really master those skills. What we do want to stress, though, is that number sense is real critical. It's a foundation that ensures that children are successful in mathematics. So we need to really make sure that we're taking the time in those early grades to focus on number sense. And we'll talk today how it impacts in the later grades. All right. So this learning progression of counting and beginning number sense was created from the work of John Vanderwall, Doug Clements, and Julie Sarama. It's really similar to other natural progressions, such as a child first learning how to crawl, then walk, then skip, then jump. However, remember, in real life, there are children out there that may learn to walk before crawl. So some of these concepts may come in a different progression. Some students may skip some of these stages, and it depends on the learner. So what's important to know, based on what Doug Clements and Julie Sarama say, is that this progression really helps teachers understand the varying levels of knowledge exhibited by individual students, which in turn will help you to better meet the needs of all children. So just really quickly, I know we do have some older grades teachers on here as an interventionist. So subitizing is really just quickly recognizing a number of objects in a small set. When students are able to do this, they move past that one-to-one counting phase. They just know that there's 3 there. And it really helps upper elementary grades during multiplicative thinking. So with comparisons, children are learning that concept of more. They know at an early age that somebody has more food or their brother has more toys, etc. But this is a good concrete representation. Students can visually see the difference. And it's okay that they don't tell you exactly how many. They don't need to count the objects in the comparison stage. It's really about that visual recognition, which ties in with subitizing. And then I like to talk about counting one-to-one correspondence and cardinality together. Think of young children when they're singing the ABC song. They know those letters, but do they actually know what those letters mean? The same goes for rote counting, which is that procedure of just counting without meaning or really any true understanding. So teachers can introduce counting tools like a number path or a 100 chart to help support that counting sequence. One-to-one correspondence and cardinality. So after children learn that sequence of numbers, then you're able to introduce that one-to-one correspondence. And that means that a child can connect one number with one object and then count them with understanding. We want to elicit the idea that over here you can match one star with one cube, and that's one. And cardinality is that how many, when they get to the end, once they've counted them all, how many? Do they need to go back to that one to start counting again, or can they say 6? All right. Hierarchical inclusion. It's something that children discover when they practice counting and one-to-one correspondence. It means that there's numbers nested inside of each other. For instance, in this one, the number 4 is inside of 5, and 5 is the same as that 4 plus 1. So you can practice this concept by asking students to count a set of 7 objects, and then to ask them to show a smaller set of 5. Do they just kind of push 2 off to the side, or do they start at the very beginning and count that set of 5? So concrete representations are really important at that level of learning. And then the big idea of number conservation is derived from the hierarchical inclusion. So students at this level are starting to learn there's a decomposition of numbers happening. And number conservation means that the number of objects remain the same when they're rearranged spatially. So if you look here at the hearts and the lightning bolts, most students will say that those are the same. However, if you gave them a visual like this, there might be some students of yours that say, no, they're not the same because they don't understand that that number conservation yet. So continuing to expose students to objects in a variety of arrangements and continue to connect the idea to one-to-one correspondence will help with number conservation. So lots of big ideas within number sense. So what does this look like towards middle school, Shantae?
Yeah, so when we think about the progression, we know that as students learn things, especially in math, that there's a progression that exists. And number sense is that foundation that students need in order to progress to higher levels of mathematics. Specifically here, we're looking at the progression towards students being able to successfully engage in middle school algebra. Thank you, Toni, for dropping that link in the chat there. So we can see, hopefully you can see, if you can't, definitely click on the link that Toni put in the chat there, and you'll get a better, clearer, bigger visual that we're showing you here. If we look in kindergarten, we see that it's very important that students know number names and counting sequence. They're able to count and tell the number of objects. So that progression that Toni was just explaining is the foundation of students progressing to first, second, third. So these skills build upon each other. And this trajectory, as long as students are successful in these number sense routines at the various grade levels, they will be adequately and more prepared to engage in middle school algebra and even go further from there, even more higher and more advanced levels of mathematics. Next slide, please. So why routines? Why are they so important? Why are we spending time today engaging with you around number sense routines? Well, this quote here says that students need quick, explicit daily experiences with number sense concepts. Routines provide that structure, and its purpose is to provide a daily experience with a number sense concept. The ultimate goal is that students make connections over time, build an understanding of relationships among numbers and operations, and ultimately apply their number sense understandings in problem solving. And this is from the number sense routines. So what I would like for you to do is think about what word or words really resonated with you from this quote. And you can go ahead and type that in the chat. What word or words resonated with you from this quote? Okay, I see daily, explicit, daily experience. So that idea of making sure that these routines are consistent and a part of a normal routine for the students every day. I see Kelly put in there structure. Absolutely. Thank you all so much for engaging. making connections. Quick, there we go. That time, we know that time is of the essence. So we do, you will notice in these, a lot of the number sense routines there, that they are something that there is a specified amount of time for each one. These aren't something that necessarily would take the entire math block. Next slide, please, Toni. So through our time today, what we're going to do is Toni has so graciously broken up our number sense routines into 4 big buckets. So we're going to be looking at routines that require visual images. We're going to be looking at number sense routines that require estimation and estimating techniques. We're going to look at some routines where students are reasoning. And we're also going to be looking at routines that require students to use some mental math. So some of the routines we will actually engage you in the webinar. And there's some we're just going to provide you information about why these routines are important and vital for students. And then you do have access to a description of the routine, and you have some links in the participant deck to get to the specific routines. And there's some videos provided and some examples, all that good stuff for you in the participant copy.
All right, so let's start off with some visual images. This one may be very familiar, this notice and wonder routine, which really encourages all students to be active participants by asking them to notice and wonder about a prompt or an idea. This routine really helps to encourage active learning, develops critical thinking. It establishes a safe classroom environment because all answers are accepted as a reason of what they notice and what they wonder. It also can be used to spark student interest. It could be used as like a hook, and it helps students to see problems in big picture ways. So an example is this picture of this barn. And I actually took this from ICTM, from their classroom resources for notice and wonder. When I was looking through the different grade levels, something that surprised me was that the same image is used for the K2 grade band, the 3-5 grade band, the 6-8, and the 9-12. So it's thinking about the different types of math that could be involved at all these different levels. So in K2, you could be talking about the shapes that you see, or thinking about the barn being taller or shorter than trees. So definitely thinking about naming shapes and figures by names or attributes. In grades 3 through 5, you can start talking about quadrilaterals and parallelograms or angles. You can talk about perimeter, an area. In 6 through 8, you can talk about properties of quadrilaterals. And in grades 9 through 12, the angles and the polygons. So here's an example of just one image, this prompt that you can use with various age bands to kind of elevate what they're noticing and wondering, and then connecting it to the mathematics that you're working on. All right. How many? How do you know? So again, this routine uses a visual image that particularly leads towards counting that quantity. That cardinality of how many. And it really kind of gets students to kind of think about the different ways that they can count, and then kind of explain their reasonings for how they got the number that they got. So this math routine really gets kids talking about math. It encourages noticing about math in just everyday objects, allows access for all students. It really helps to promote and build their math confidence, again, because they're easily able to say and respond to the question of how many, can spark curiosity, and it opens students' eyes to different perspectives. So somebody may count something that they didn't even think about. So here's just an example from a 4th grade classroom, image of Legos and various student responses. So we see everything from 15 blocks to 101 circles to 96 circles. All right, charting these out, attaching the students' names so that their thinking is visible. All right, Shantae is going to walk you through the next one.
All right, so our next visual image, we have our dot talks, or quick images as they are referred to. And these images really helps students recognize quantities without counting. So there's really big emphasis on that. It helps students to recognize the spatial arrangement of the dots. So they may talk about something being horizontal or diagonal or vertical. And they also help students to recall number pairs quickly. Next slide, please. So the idea behind there is that we're showing an image, we show it really, really quickly, no more than 3 to 5 seconds. And then you get students to engage in how many dots were there, and more specifically, how they saw them. So the examples that you see here, there's a K to 2 example, as you can see, just a few dots there. And then we have a 3rd to 5th grade example where there's a larger number of dots and they're arranged in a specific sequence. Within the participant deck, we do have links to the images, that the examples that you see there, so you can click on those links in the participant deck to get more access to the images. Next slide, please, Toni. So for the dot talks, we do have videos in the participant deck as well. Okay, so definitely please look at those when you have some time.
All right, so the next routine is called splat. And this also can be used for any grade level. Students are shown visual representation of numbers, usually they're in dots. And then with a splat, which is like a cover over it, part of the representation is hidden and students have to figure out how many are still showing based on how many are hidden. So this routine helps students develop that visual approach to solving equations. It promotes algebraic reasoning, subitizing, and parts of a whole. And at higher levels, splat can be used to fuel the understanding of equations, remainders, variables, and there's actually even a splat fraction for the older grades. So we are actually going to engage in this one. So let me go out of here, go to this one. Okay, are you seeing splat? Okay, let's see if this works. All right, so this one is, all right, so here's our sets of dots. How many blue shapes do you see? Go ahead and drop a number in the chat. All right, I see. How many blue dots or blue shapes do you see? All right, getting a lot of 10s. Anybody see anything other than 10? Right. You're right, there's 10 there. All right, here's our splat. How many shapes are under the splat and how do you know? So add your number to the chat, but also tell me how you know how many are under the splat. I see a lot of 8s. All right, 2 plus 8 is 10, all right. 8 because there's 2 left, so I see some equations starting to happen here. 8 minus 2 equals, I'm sorry, 10 minus 2 equals 8. 8 because we started with 10 and there's 2 left. Oh, counting backwards. 10, 9, 8. So different strategies are appearing here. All right, good. Can you know another way? If you said because you saw 2 or you counted back, is there another way now that you can figure out how many are under the splat? Ooh. So I'm starting to see some other ideas now. Something plus 2 equals 10. 2 plus something equals 10. All right. Let's look under the shape to see how many shapes there are. How many shapes do we see under our splat? We're definitely seeing our 8s. All right. What could you learn from this picture right here? Or what could your students learn from this picture? What does this visual representation help them to see? Okay, a missing add-in, a fact family. 8 less than 10 is 2. Definitely, yeah. So this is just another way when you're thinking about those facts or thinking about those missing add-ins, just a visual routine that can help to support that Yep, visualizing in a different way. Yep. All right, let me get back to the other presentation. All right, do you see estimation now? Okay, all right. So let's go ahead and dive into some estimation strategies now, and routines now. Okay, so the first one is estimistry. And this one allows students the chance to really hone in on those estimation skills, which really helps to support number sense. So this routine, students are shown a picture and have to determine how many total objects, but then they're given clues, so then they can actually refine their estimation and try to narrow down the options. So this routine helps students develop skills such as that estimation, finding missing numbers. It helps them develop number sense, as I mentioned, and also confidence as they're learning to justify their thinking with why they have maybe a too high estimation, a too low estimation, and maybe what their just right estimation is. It helps to develop math reasoning as they use math concepts to narrow down the possibilities. Also highlights math vocabulary by using, greater than, less than, even, odd, prime, etc. So here's an example of estimistry with the clues, and those clues are revealed one at a time. Similar to estimistry, we have estimation 180. Shantae, I think you're taking this one, right?
Yes. So with estimation 180, students are, again, they have a visual representation, and this is something that you can make on your own. You can grab a jar, something that's clear, that's see-through, that students can actually see, and fill it with some type of small objects. And then you want to get your students to make a reasonable guess or estimate about how many of the objects are in this jar. This is a great activity for students to estimate using visuals and to learn more about topics like money, fractions, measurements. Students are also reasoning with estimation 180, and they have to justify their reasons and reflect on their estimates. So this really is getting them into that mode of, does my estimate make sense? Is this a reasonable estimate? We know we always see reasonableness when it comes to estimation. So this type of activity will get students the ability to start exploring that concept of reasonableness. Students are also using mental math to determine the quantities that are in the jar. And we're also getting students to think about spatial reasoning, to apply that when they are estimating. Next slide, please, Toni. Okay, so here we just have some examples of a few different things that you could use in terms of having students do the estimation 180. And then on the side there is just students actually doing a written version of it. So they're putting down their estimate, explaining why, and justifying their reasoning, in this case, with some words and a picture as well. Somebody estimated that there's one cheese ball on the plate. I think that's a very great estimation. Next slide, please. So our next routine that we have here is open middle. And the open middle, this is actually an activity that we're actually going to engage you in. And this is a great routine to get students to defending their answers and how they got from this part of the problem to this problem. And the good thing about this routine as well is that it's not an activity where students are following a solution path laid out by the teacher. The path is completely in the control of the students. So for this activity, you show the students an open middle problem, and we do have linked in here a website that will take you to a plethora of open middle solutions and problems. So you're going to show them the problem and actually give them time to think. They always need that think time. And then after students have thought about it, you want to give them time to actually share out their strategy. As they're sharing, as you're facilitating the activity, you really want to ask these probing questions around, how did you do that? And why did you do that? And why does that make sense? Really probing the students' thinking around what they put there, even if it's a misconception. You still want to ask those same questions to really get students to think. And hopefully by asking those questions, they will discover their misconceptions. So in the chat, Toni has put a couple things. These are actually two Jamboards to two different open middle activities that we would like for you to engage in. So there's a primary open middle And then there is an intermediate open middle. So we would like for you to choose which one that you would like to engage in. Click on the Jamboard, and then actually go ahead and read the directions there and engage in the open middle activity. So to make sure that nobody else gets your slide, when you open the Jamboard, go ahead and put your name on the slide there so that nobody else will go ahead and engage in that one, and they'll know that it belongs to you. There should be enough slides for everybody. There's 20 slides for the primary, 20 slides for intermediate. So we'll go ahead and give you a couple minutes to explore around in that. And then as you come up with some solutions, let's go ahead and drop them in the chat. Let us know if you're on the primary or the intermediate, and then let us know the solutions that you come up with.
In order to get to the other slides, if you haven't worked with Jamboard in a while, I'm showing up here. If you click under that 1 of 20, it will show you the different ones, and you can hit the right arrow to get to one that somebody's not on. You can see like icons at the top if somebody's using it right now. Okay. Keep moving down.
Thank you, Toni, for that explanation. And again, if you just put your name or maybe initials up there on that slide, then that'll be another way to let people know that you're on that one, and they can go ahead and defer to another one. And if the primary is off field, then you can go ahead and use the intermediate. Yes, this is the last day of Jamboard. Tomorrow, no, you will not be able to utilize or create any existing Jamboards. And so we'll get the last use of it for today. All right. So I can see people engaging in this looks like are we in the primary or the intermediate? This is the primary.
This is the primary.
Yes. And again, if you would like to type your solutions in the chat or type your thinking in the chat around your solutions. Oh, we do have some people in the intermediate too. All right. I was wondering if anybody was going to engage in there. Got some multiplication and division there. Good thinking. All right. Kelly has showed her strategy in the chat there. Definitely feel free to go ahead and engage. We're going to move on for time's sake because I want to make sure that we get to our other activities that we have there. But I would like for you to maybe share out in the chat, how do you see students' number sense developing, utilizing the open middle strategy? And you can just put something in the chat as soon as you have an idea, or if you're still engaging on the Jamboard, go ahead and feel free. I know sometimes once I get to playing games or doing number routines like that, it's kind of hard to pull away sometimes. Next slide, please, Toni. So next we're going to get into some reasoning strategies. And keep the ideas coming in the chat. I see they're coming in there. Keep them going in there. We'll keep checking from time to time to see what you all came up with. And with the reasoning strategies, we want students to do just that. We want them to reason and justify and really provide reasoning as to why their strategies make sense. So the first reasoning routine that we're going to talk about is would you rather? And with the would you rather, it's very, very simple. You're presenting students a scenario. Would you rather have this or would you rather have this? Again, in the participant deck, we have a link for you I think it's on the next slide, that provides you with access to some different would you rather scenarios. And this helps students because it really helps them to use their intuition to make a choice about a scenario. It really is reflective of them. And every student has access to this, regardless of their mathematical proficiency or not, or wherever they are in the math world, they can actually engage in this task. Students are asked to reason about and make sense in very different scenarios. Students are going to be sharing their thinking with a peer. So depending on the situation that they pick, they're going to turn to their partner and say, I would rather do this because A, B, C, D, and their partner would either agree or disagree and say, I would rather do this because of all of these great reasons here. Again, students, as the title pointed out, reasoning, students are justifying their reasoning for their choice. Why did you pick this scenario? Why did you pick this scenario over this one? And lastly, students are learning from each other because they're talking with a peer. So their peer might provide for them a thought or an idea that they never even thought of, or that they never even conceptualized. So that idea of collaboration is extremely important as students are learning and exploring more with reasoning. Next slide, please, Toni. And here, again, it's just some examples of a few would you rather. Here's a primary and intermediate example, and the link at the bottom will take you to some more examples as well. And I believe there's also a couple of videos. There is a would you rather middle school video in the participant deck for you to explore as well.
All right, so the next routine here for reasoning is guess my rule. And this one really helps students in thinking about a set of numbers and what is the rule that is, or the relationship between the two of them. So they figure out a rule for categories, or, making some, statements, conjectures, and really testing out their ideas. So this routine, again, supports a demonstration of number sense around what numbers mean. Also thinking about the relationship between numbers as they're kind of determining what the rule is that describes them. This routine can also support algebraic thinking as students apply concepts that they're developing in patterns, functions, etc. You can use operational skills with this, with positive and negative integers. Students are, again, using language to communicate their math ideas. And they're sorting and describing attributes based on those rules and descriptions of the objects. So in this case, with Guess My Rule, again, you're giving them a set or sets of numbers or objects. You can put them within a circle or in an input-output box. And then they're trying to determine what the relationship is. So here's a few examples. We definitely have some primary ones here, some more intermediate, and then a little bit further down the line, like 5th and 6th grade, when you're thinking about the variables. Okay, so students can be kind of thinking about why the things in the middle are in the middle and the things are on the outside of the circle on the outside. Same thing with the one with the different squares, quadrilaterals. Okay, and then we have the input-output boxes. So what's the rule that goes from that input to the output? Again, we have a video or two. One is a primary with a Venn diagram, and then there's I want to say there's a 6th grade one, which actually incorporates Guess My Rule with a lot of movement. So the kids are actually moving around the room, which I tend to appreciate that, especially as you get older. You don't tend to get up a lot unless you're going to the whiteboards, to do some problem solving, etc. So check out those videos as well. All right. And then we have same but different. You might have heard about this one. A lot of times I see this in those primary classrooms that I get into, but it can be used for any grade level. Simple routine that builds a connection between important math ideas where you're kind of engaging in shared meaning. So you present either two numbers, two shapes, two equations, etc., to be compared. And then students have to use the, they have to reason and, think about why they're the same as well as why they're different, and then also justify their answer for each. So one of the good ideas to do after this is thinking about summarizing students' idea, having other students restate the ideas helps kind of call attention to what they're hearing their partner saying. All right, so here's an example. We're going to go ahead and engage in this one. Look at this image. How are these two things the same but different? So take a moment to think. If I was in the classroom, I might have you turn and talk to an elbow partner to come up with your ideas about how these are same and different. And then we would share out as a whole group. All right. So Aaron says the same amount of dots. So the little pips, there's the same ones. Okay. Adam says that they're different because of the colors. Michelle's saying they both involve numbers 3 and 4, but in different ways. So she gave her reasoning for same and different all in one response. All right, Callie says the sum of 12, but there's a different number of cubes. So one shows 3 cubes, one shows 4 cubes. All right. So this is just what we would do with our students, have them turn and talk, share these out, chart out some on one side, differences on the other side, and then kind of bring everyone together and talk about all the different ideas, all the different perspectives, where students are kind of, moving towards a generalization of a larger concept. The green ones are more in a tall rectangle shape and the pink ones are in a square shape. I didn't think about that one. So definitely different ideas. Again, promotes access for all students to be able to engage in this. All right, Shantae, I'm going to pass it back to you for our mental math.
Thanks, Toni. I appreciate that. So now we're going to get into some number sense routines that really ask students to engage mentally. Our first example here are math talks or number talks. And actually, when I was a classroom teacher, this is one of my most favorite routines to do. Very, very few materials that are needed. And the idea behind there is that students are using their mental math strategies to come up, they're using mental math to come up with a multitude of strategies for the math talk or number talk that you're presenting. Students are reasoning about relationships and their numbers. Students are making connections in math. And they're learning strategies from their peers. I can't count the number of times that I can recall a student sharing a strategy and they would label it with the student's name. So say, fast forward a week later, we're doing a math talk or a number talk, and a student would share out, well, hey, I'm going to solve it the way Toni did it. I'm going to use Toni's strategy and share out how Toni solved the problem last week. So the idea here is that you present a problem for students to solve. And students think of lots of different ways that they can solve the problem. And then students use signals to say how many different ways they have to solve the problem. So I have one way to solve the problem, 2, 3, so on and so forth. You start off by asking for the solution. So right away, we want to get the solution. And as a class, we're going to come up with a consistent answer. We're going to decide together which one of these is the answer if there's multiple answers. And then from there, we're going to talk about our strategies. How did you get the answer so-and-so? So now I'm going to call on students to share. I'm going to write their name, and I'm going to do an abbreviated version of their strategy for the math problem that they were solving. Next slide, please. So here you can see an example of a math talk or number talk. There's a primary example and an intermediate example. Again, links in the participant deck will give you resources and access to more math talks or number talks that you could possibly engage students with.
All right. And then another one for mental math is number of the day. And this is a routine where you focus on a specific number, and students come up with different representations of that number. So present them with a number, and they are allowed to use, if they want to use concrete items such as 10 frames, base 10 blocks and counters, they can use that in their representation of what makes that number. Throughout this, you just kind of asking those open-ended questions. What do you know about this number is a great way to think about the responses that you're going to get from your students. The math skills that can be highlighted throughout number of the day. Thinking with the early ones, it's number writing. Are they writing their numerals correctly or spelling out the numeral word? Are they identifying if it's an even or odd number? Are they working towards place value with identifying the tens, ones, and hundreds of a number if you're using a 2 or 3 digit number? Comparisons, Are they comparing a number to another number by saying it's like 1 more than or 10 less than? Number composition and decomposition. So what types of numbers can they put together to make that numeral? And then using that towards the basic operations, and are they starting to create addition and subtraction equations for that number of the day? So here's an example of, I believe this was a 3rd grade, and what it would look like for the number 35. So you see the 7 times 5. You see the 10 frame, I'm sorry, not the 10 frame, the rods and the ones for the 10s and the ones. So you have the 10 plus 10 plus 10 plus 5. All right, you have 35 plus 0, or 0 plus 35. And then you see some decomposition happening with numbers. And you see some skip counting. All right, so we're gonna go ahead, and this will be our last one that we engage in today. And we are going to try this for the number 28. So let me drop this in the chat. Going to another Jamboard. Look at us getting our fill. All right, number of the day. Okay, so do you see the number 28 on the screen? All right, all right. So everyone should have edit access to this. If you click over here on the pen, you can click there and actually use your mouse to write your representation or draw your representation of 28. Or if you'd like, you can click on a sticky note and write it on a sticky note and just kind of post it on the screen as well. So how could you make 28? What do you know about that number? So I see some decomposition here with the 20 plus 5 plus 3 equals 28. All right. Oops. Yep, I see some post-it notes. Let me just kind of move those over. Yep, that's okay. All right, so we have 20 tens. Oh, 2 tens and 8 ones. Okay. Another. And we have 10 plus 8. I'm seeing 4 times 7. 30 minus 2. 15 plus 13. And then to elevate for whole group conversation, I might go to the person who said 15 plus 13 and say, how did you get the 15 and the 13? Where did you see 15? Where did you see 13? And then have them kind of explain to the class how they came up with that equaling 28. All right, great examples. Ooh, 100 minus 72. All right. Thinking the big numbers. All right, thanks for sharing. I'm gonna go ahead and jump back. Whoops, I don't know how to get rid of that. All right, Shantae, I'm gonna pass it back to you.
Thank you, Toni. So if we're spending time, and based off of what we've said so far, I'm pretty sure we all would agree that number sense routines are important, are vital to students getting that foundation for math that they need to progress further in math. When can these routines happen? When does it make sense to implement some of these routines in the classroom? So first off, we want to start off by saying that we really want this to be a natural part of the classroom and not number sense routines be something necessarily separate or an extra something that you can do. So we want you to think about, how can you think about right now and actually share in the chat, when can these number sense routines be utilized in your math block? Let's see what you think first. Go ahead and put some ideas in the chat. Okay, so I said, Ann says during our warm up. Okay, beginning or end of the math lesson. Warm up or cool down, morning meeting exit ticket. Okay. Anissa said she uses them as a warm up as an intervention teacher. Some really, really great ideas coming into the chat during our morning meeting, before a break. So use that as kind of like a transition. Again, a warm up. All right, keep those ideas coming into the chat. Tony, you can go ahead and go to our next slide there. So if you look on here, a lot of the examples that you all gave, or when these number sense routines can be utilized in the math block, you've already shared with us. So they can be used during that launch, during the beginning part of the lesson, when I'm trying to ensure that students have access to the math. One great way to get access for students is to actually have them do a number sense routine as they do now, or as students are coming in for breakfast and we're getting started with the day. We know that the beginning in the morning, it's a lot going on. You might have people turning in homework. You have kids hanging up book bags. You got to do your lunch count or breakfast count, all this stuff. So it'll be a great beginning of the day activity to have one of these number sense routines either on the screen or on the dry erase board for students to start engaging in. If you were like me and we would start off our day on the rug and we would talk about the day of the week and the calendar and all that good math stuff in the beginning of the morning, we call that mathematizing a day. So as you have students sitting on the carpet or the rug and they are engaging in the day of the week and what day it'll be a week from today and what day it'll be 2 days from today, all those wonderful math routines, that's an actual great time as well to have students to engage in these number sense routines. And lastly, as a spiral review. So I think someone said in the chat at the beginning or the end of the lesson. So if an assessment is coming up or students are getting ready to take a test, these number sense routines are a great quick way to review some of those key concepts, as opposed to having students do on a worksheet with 15, 20, 30 problems. You can have them do just as much math by utilizing one or more of these number sense routines.
All right. And then the why. Why number sense routines? Think back again what I had said, I think earlier in the beginning, about number sense really being the key skill for success in math, and it really has an impact on students' mathematical ability in the later grades. It's also the single best indicator of students' math success. All right. So number sense is an important skill because it builds relationships with numbers. It really helps children to understand how numbers relate to one another and how our number sense system works. It develops flexible thinking. So children with good number sense are able to be flexible with their approach in solving problems and can adapt their strategies to different situations. So like the math talk or the number of the day, maybe some of those strategies that got elevated there, a student might tap into one of those strategies and then apply it in a later situation, a later problem, or a later math talk. Helps students to become more confident. It really helps them when they have that ability to work flexibly and understand the relationship with numbers. It just builds up their confidence. Helps them to solve problems more efficiently. So it helps them to find the more efficient solution to a problem. So they might go like, let's say the number of the day is 10, they might go something, like 2 plus 2 plus 2 plus 2 plus 2 is 10, but thinking about efficiency and efficient solutions, and maybe they're in third grade and they're starting to learn multiplication, they might be able to do the 2 times 5 then. It's a little bit more efficient without a lot of writing them down. Develop an appreciation for math. Really helps when we're doing these routines because they're so quick and they're giving access to all students, to kind of empowers them to realize that this math exists everywhere. How Shanteau was also talking about mathematizing the day. Math exists everywhere, and the more that we can show this to students, they'll start appreciating the math and becoming more confident in it. And that really does establish that foundation for more advanced math. Math concepts and strategies such as fractions, decimals, and algebra.
All right, so it's 4:28. We thank you all so much for joining us here today. We do want to wrap it up with a reflection question, and we want you to think about what is one number sense routine that you want to try within the next week with your students? It could be something that we mentioned here. If it's a routine that maybe we didn't mention and you want to highlight it, that this will be something good that you want to try, you can drop that in the chat as well. We really want to be actionable and really get you using these number sense routines as soon as possible. So go ahead and drop in the chat something that you would like to have your students engage in as soon as next week. Okay, I see someone put in here the doing the dot talks or the number talks. Splat, yes, splat is cool, and it can go so many different ways. So cool. Oh, cool, Megan. I hope it goes well. Your number talk presentation for college or the class access my students. Oh, cool. So definitely lean into some of those resources that we put in there. And there's also a one pager that gives you some directions as to how you can facilitate the math talk. Okay, Sarah's going to share websites with her teachers, encourage them to add into their daily routines. Absolutely. Julie's going to do Would You Rather? Yes, share these resources, share these links. That's what we're here for. We do not want to keep this information for ourselves. Michelle's going to do Which One Doesn't Belong. We are lowering correlation. Oh, awesome. I'm pretty sure that will work out very, very well. So keep the ideas coming. I'm going to go ahead and continue on. So we also do have some video examples and resources for you here as well. We have links here to Graham Fletcher's progression videos. These are absolutely amazing. I definitely encourage you to look at them when you have time. It helps show the progression of some of these vital mathematical concepts so you can really see how students progress in addition and subtraction, how they progress in their early counted number. These videos saved my life when I was an educator in the classroom. So definitely refer to those. And we also have some additional resources for you here around Would You Rather, Same or Different, some estimation challenges, some number talk images. Those are here. And again, on each of the slides for the number sense routines that we presented for you, there are links for the different activities, videos, examples, so on and so forth. We thank you all so much for engaging with us today. We are happy that you took time out of your afternoon to come and talk with us some more and learn more about some number sense routines. And please feel free to reach out. I'm kind of speaking for Toni, but I don't think she minds. Please feel free to reach out to Toni or myself. Share with us something that you did in your classroom, how it went, and we would definitely love to connect with you as well.
Thank you both so much, everyone. Round of applause for Toni and Shantae. Thank you for sharing a wealth of resources. And I have to say, you definitely want to download these slides because all those links in there go to sites that are just filled with pre-made examples and videos. There's just, you could spend just, there's so much to learn in the links there. So thank you both for sharing a well-organized collection of just great number sense and number talk routines. I do want to remind people that if you are an ICTM member and want the PD credit, make sure you do check out at the checkout form that's on the slide I put back in the chat, and make sure you do register with ISB to let them know that you were here. All those directions are there. And we'd love for you to join us in about 3 or so weeks. I think it's Monday, October 21st is our next Math Monday. And we're going to be talking about opening up math problems. And Annie Forrest, a past ICTM president and current math education consultant, is going to be talking about ways to take math problems and change them a bit to really open up conversation in your classrooms around problems you may use every day. So we look forward to seeing you back for Math Mondays, October 21st. And we are finished. Thanks again, Toni and Shantae. And yeah, we really appreciate your presentation. And I know there's at least one person who was in a car and was asking about the slides. We will post the webinar and slides on our website soon, but you can also email info@ictm.org and we can send them to you directly as well. So info@ictm.org. But thanks, everyone. Have a great week, and thanks for being a teacher. We love having you as part of our ICTM community. Bye, everyone.